Today we're going to continue with how to name organic functional groups. We're going to start with our carboxylic acids. In our carboxylic acids, we're going to be using the IUPAC names, where we're going to take the alkane name and change the ending from E to oic, and then add the word acid to it. So what we are looking for is a carbon with a hydroxide group on it, as well as a double bonded oxygen. So the methanoic is going to only have one carbon on it with the hydroxide group. Ethanoic, on the other hand, we're going to go methane, take the E off, add OIC, and then the word acid. For ethanoic, we're going to have a CH3 group onto the carbon with the double bonded oxygen and the hydroxide group. For the propanoic, we're going to have a CH3, a CH2. Next is going to be the carbon that's going to have the hydroxide group and the double bonded oxygen on it. So let's try this next one really fast. We're going to put a CH3 group with a CH on another CH group. Oh, that should not be a 2 there because we're going to have a fluorine on the third one and we're going to have a chlorine on the second one here. Okay, and then we're going to have a CH2 connected to the carbon with the double bonded oxygen and the hydroxide group on it. So this is going to be our first one because it's at the double bonded. 2, 3, 4, and then 5. So we have 5. That makes it a penta. So this is going to be a pentanoic acid. We're going to add take note of our groups. So we have a chloral and a fluoral. The chloral is at carbon number 4. So this is 4-chloral. And then our fluoral is at 3, so it's 3-fluoral. So the name for this will be 4-chloral 3-fluoral pentanoic acid. Okay, our next type is esters. Our esters are going to have a carbon group connected to a carbon with a double bonded oxygen with another oxygen, and on the other side of the other oxygen is another carbon group. Okay, so CH3COOCH3. We're going to put our CH3 with our carbon with a double bonded oxygen connected to an oxygen with a CH3. The part that is connected, whatever carbon group is connected to the carbon with the double bonded oxygen is always the longest chain. Even if it's shorter than the other side, it's still the longest chain. So in this case, we're going to have a methyl group connected to an ethanoate. So this becomes methyl ethanoate. The ethyl comes from the longest chain. The methyl comes from the branch. Okay, so now we're going to put a CH3 with a C with a double bonded oxygen and an oxygen on it. And then connected to that oxygen, we're going to put a CH2CH3. So I see on the oxygen side, or my branch side, becomes an ethyl. And then the longest branch side is also ethyl, so that becomes ethyl ethanoate. All right, CH3, CH2, or no, just a CH with a bromine connected to it, connected to the carbon with a double bonded oxygen. The oxygen side of it is going to have 4 carbon groups connected to it. So CH2, 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 CH3. All right, our longest chain is going to be this propyl, and then our other chain is going to be 4 of them becomes butyl. And then we have a substitution on here of bromo. They start at the double bonded oxygen carbon, that's 1, 2, and 3, and then that makes the bromo on the number 2, so this is 2 bromo. Then is butyl, that's the branch on the oxygen side, and then is propanoate. If only I could spell. Something's not right there. All right, I'm going to cross that off. I'm going to write it the right way. Propanoate. All right, branches are only on the long chain here. Make sure we write that. The branch is only on the long chain. Because our groups can't have a branch on it because they're not numbered. All right, next one we're going to do are called amines or amines, whichever you prefer. We will be using the common name for this, where all we have to do is find the group connected to the amine. The amine means that the NH2 is always an N group. So this CH3, CH2, that's an ethyl, so this becomes ethylamine or ethylamine, whichever you prefer to say. All right, so we're going to put CH3, CH2, CH2, NH2. There's 3 carbons here. This becomes propylamine. We're going to start our numbering at the nitrogen side every time we do that. So let's do another one here. CH3, CH2, CH2, CH2 with a nitrogen. And on the top one, we're going to put a methyl group. And then we're going to have a hydrogen on the bottom. Whenever it's connected to the nitrogen, you're going to put an N as the designator. So this would be N with a methyl group, butylamine, because there's 4 carbons there. So our branch is on the nitrogen here. All right, so let's try another one. CH3, CH2, 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 nitrogen. And we're going to put 2 methyl groups on it. All right, so it's going to be N, comma, N. But now we have 2 methyls, so that becomes dimethyl. And then we have 4 carbons in our longest chain, so this becomes butylamine. Okay, the final type are amides. Amides have a carbon with a double bonded oxygen connected to an NH2. And this is always going to be an N group. Looks like I cut the video off a little bit on the top here. I'm sorry about that, guys. Just know that there's a double bonded oxygen on top of there. This is the IUPAC method. We're going to have a hydrogen connected to a carbon connected to a double bonded oxygen connected to an NH2. Since there's 1 carbon, this would be methane, so we take the E off and make this methanamide. If I have a CH3 connected to a carbon with a double bonded oxygen and an NH2, there's 2 carbons in this. It would be ethane, so we take the ethane and change it into an ethanamide. All right, we're going to try a CH3 with a with a bromine connected to it, with a CH2 with a carbon connected to a double bonded oxygen connected to a nitrogen. But we're going to substitute, just like we do with the amines, we're going to substitute on the nitrogen with a CH2, CH3, and then CH2, CH2, CH3. So an ethyl and a propyl group. When we number our carbons, we start at the end group because we got to get to this bromine. Okay, so here's all of our groups. Start at the carbon closest to the amine, and 1, 2, 3, and 4. That means our bromo is on number 3. So we start with 3 bromo, and then this ethyl group is on the nitrogen, so it's an N ethyl. The propyl group is also on it, so it's N propyl. And there's 4 carbons in that chain, so it's butane, so it's butanamide. All right, remember tomorrow you guys are going to be at the impact. Work on your esterification worksheet that we gave you today and have a good time. I'll see you guys on Wednesday.